Let's take a look at this example. This time we're supposed to find I3. I3 is the current which will go through resistor R3. Please notice that resistor R3 is connected in parallel, okay, with my voltage source E. So simply you're supposed to realize that the voltage across resistor R3 is equal 10 volts because these two components are in parallel. That's why I'm going to write that I3 is equal E over R3, where E is equal 10 volts and R3 is equal 5 kiloohms. This is equal 2 milliamps. Okay, so I found this. I found I3. Next, I can find Vs very easy. Why? Because my current source is connected in parallel with my voltage source. So the voltage is going to be the same, okay, because this is the same point, okay, and this is the same point, so they are connected in parallel. That's why I'm going to write that Vs is equal E, and this is equal 10 volts. Okay, we found this. Next, we can find also V1. Please notice that the voltage between this point and ground is equal 10 volts. Okay, so we can say that Vs is equal to E, this is equal 10 volts, and this is also equal to the voltage V12, means voltage across these two resistors. So if you want to find V1, voltage across this resistor, you're supposed to simply use a voltage divider formula. We use this is going to be V12, okay, V12 times R1 over R1 plus R2. So my V1 is equal V12, we found this is equal 10 volts, times R1, which is equal 2 kiloohms, divided by R1 plus R2. R1 plus R2 is equal 5 kiloohms, because 2 plus 3 is 5. So this is equal 10 times 2 exponent 3 divided by 5 exponent 3 is equal 4 volts. Okay, so we found V1. Next, we're supposed to find P2. P2. So how can I find P2? Simply find V2. V2 is equal V12 minus V1. Okay, this voltage between this point and this, minus voltage across resistor R1 will give me voltage across resistor R2. So V12 we said is equal 10 volts minus 4 volts is equal 6 volts. Next, we're supposed to find power P2. So P2 is equal V2 to the second power over R2. This is equal 6 volts to the second power over R2, which is equal 3 kiloohms, and this is equal 6 squared divided by 3 exponent 3. This is equal 12 milliwatts. 12 milliwatts. Okay, we found P2. Next, we're supposed to find the current which goes through this voltage source. Okay, so what we're supposed to do first? We're supposed to find the current in these two resistors, because we have already this current. So now we're supposed to find the current which goes through these two resistors. So we can say that my I12 is equal I1, this is also equal to I2, and this is my simply voltage V12 over R12, where V12 is the voltage between this point and ground. Okay, so this is nothing else, just my E, so I can say this is E over R12. So E is equal 10 volts over R12, R1 plus R2 is equal 5 kilo ohms, so this is equal 2 milliamps. Okay, so this is the current which will go through resistor R1 and R2. So next, what we're supposed to do in order to find IE, you're supposed to realize that my IE is going to be equal my I source minus I12 and minus of I3. Okay, so I source is equal 9 milliamps, my IS, minus the current which goes through these two resistors. So I have my I12 2 milliamps minus the current which goes through resistor R3, and current through resistor R3 is equal 2 milliamps. Okay, so I have 2 milliamps, so this is equal 5 milliamps. So if IE is equal 5 milliamps. Okay, so my current IE is going to go this way. My current R3 is going to go this way, and my currents R1 and R2, this is basically the same current, is going to go this way. Okay, so why it so? Because all values, right, all values which I obtain, right, are positive. Okay, so if it comes to the currents, we get what? Positive. So it means that the current goes to the ground. Okay, I3 we obtained also positive. So it means the current goes to the ground. So these are the directions of the currents, and basically IE also is positive, so it's going to go this way. So we can say that the problem is solved.